Alright, good morning and welcome back from the Easter break. Today, we'll be looking at trigonometry identities. That is, we'll be looking at compound angles, double angles, and then try to see if time will permit us to look at half angles. Trigonometry identities. Let's start by first establishing our trig ratio. So let's draw a right angle triangle. So we have our point of origin over here. Good. So we have our y, have our x. Let theta represent this angle. Let's establish our 90 degrees here. So from triangle O, say A, B. Sine theta will be equal to opposite on hypotenuse. So y over r. Cos theta will be equal to adjacent on hypotenuse. So x on r. And tan theta will be equal to opposite on adjacent. So y on x. Now, from triangle O, A, B, considering Pythagoras theorem, so from Pythagoras theorem, r squared will be equal to s squared plus y squared. Now, let's divide through by r squared. Divide through by r squared. Divide through by r squared. R squared on r squared will give us 1. This will be equal to x on r all squared plus y on r all squared. Now, let's come back here. X on r is the same as cos theta. So now you are coming to substitute cos theta into this equation. So x on r is the same as cos theta. So we have our 1 here. We go to cos theta squared. You bring the square plus y on r. Y on r is sine theta. So write sine theta squared. So now you say that sine theta squared plus cos theta squared is equal to 1. First equation or first identity. So sine theta squared plus cos theta squared will be equal to 1. So from the first identity, from equation 1, we can say that sine theta squared will be equal to 1 minus cos theta squared. This is A. And cos theta squared will be equal to 1 minus sine theta squared. B. So the first identity is that sine theta squared plus cos theta squared should give you 1. Sine theta squared is the same as 1 minus cos theta squared. Cos theta squared is equal to 1 minus sine theta squared. Take note. We'll be using these identities. We'll be working with these identities. So take note. Okay. From the first equation, sine theta squared plus cos theta squared is equal to 1. Now, let's divide through by cos theta squared. So divided by cos theta squared. In our previous lesson, we learned that in trig, sine theta on cos theta is the same as tan theta. So tan theta is equal to sine theta on cos theta. So now sine theta squared on cos theta squared, you can just substitute tan theta squared into it. So now we have tan theta squared here plus cos theta squared goes into cos theta squared 1. This will be equal to now 1 on cos theta squared. That is the inverse of cos is secant. So we have our sec theta squared. So the second identity is sec theta squared minus tan theta squared should also give you 1. Equation 2. Equation 2. And from our main equation, that is sine theta squared plus cos theta squared is equal to 1. Let's divide through this time around by sine theta squared. Divide through by sine theta squared. Sine theta squared goes to sine theta squared 1 plus. Now, we are saying that the inverse of tan is 1 on tan, and this is the same as cot. And if tan is the same as sine on cos, then cot will be equal to cos on sine. So cot is the same as cos on sine. So this one, cos theta squared on sine theta squared, can substitute cot. Good. So cos theta on sine theta will give us cot theta, and we bring the square. This will be equal to 1 on sine. That is inverse of sine is cosec. So we have cosec theta squared. So we can also say that cosec theta squared minus cot theta squared equal to 1. Equation 3. And tan theta is equal to sine theta on cos theta. Therefore, you can say that sine theta is the same tan theta cos theta equation. Take notes. Okay, so now let's look at the question. It says that if sine A equals 3 out of 5 and cos B equals 15 out of 17, where A is obtuse and B is acute, find the exact value of tan A, sine B, and cos A. Now, if angle A is obtuse, then it means that A is in the second quadrant. If angle A is obtuse, then it means that sine A is in the second quadrant. And in the second quadrant, sine is positive. Sine is positive. And B is acute, then it means that angle B is in the first quadrant. And in the first quadrant, all the ratios are positive. So take note. So now, sine A has been given to us. Let's find sine B. We say that sine theta squared plus cos theta squared is equal to 1. This time around, the angle is A, not theta. So sine A squared plus cos A squared should give us 1. So from the first equation. Good. Now, what is sine A? Sine A is 3 out of 5. So write 3 sine A is 3 out of 5. So you write 3 out of 5 squared plus cos A squared is equal to 1. So cos A square will be equal to 1 minus 3 out of 5 all squared. You send this one to the right side. So you have cos A square will be equal to 3 square will give us 9 on 25. So cos A square will be equal to, now 1 minus 9 out of 5. Take the numerator from the denominator, so you get 16 on 25. We want cos A. We don't want cos A squared. So you root both sides. Then the square root sign will do away with the square, giving us cos A is equal to root of 16 on 25. And cos A is equal to 4 on 5. Root of 16, 4. Root of 25, 5. The question says that A is obtuse, meaning that A is in the second quadrant. And in the second quadrant, cos is negative. Cos is only positive in the first and fourth quadrant. So you have to negate your answer. So cos A will be equal to negative 4 on 5. You take note. For cos A, let's calculate for sine B before we come to tan A. Sine B. So from the same identity, sine B squared plus cos B squared should give us 1. So we are calculating for sine B. So sine B squared will be equal to 1 minus cos B squared. And this will give us 1 minus, what is cos B? Cos B is 15 on 17. So 15 on 17 squared. So you have 1 minus 15 squared is 225 on 289. This will give us 64 on 289 sine B squared sine B squared sine B squared. We want sine B, so let's root both sides of the equation. So the square root will do away with this, giving us sine B will be equal to root of 64 is 8 on 17. Don't forget, B is in the first quadrant, so sine is positive. B is in the first quadrant, so sine is positive. Good. So that is the value for sine B. So now we can go ahead and calculate for A. Now let's start with this. Tan A will be equal to sine A on cos A. Tan A is equal to sine A on cos A. And what is sine A? Sine A is 3 out of 5. So you write 3 out of 5 on cos A. In cos A we had negative 4 out of 5. So negative 4 out of 5 tan A. So tan A will be equal to 3 out of 5 times the reciprocal of negative 4 out of 5. So negative times negative 5 out of 4. So this here 1, negative 1. So 3 times negative 1 will give us negative 3 out of 4 times this 4 tan A. So tan A is equal to negative 3 out of 4 for tan A. So that is how we use the three identities. So we are now coming to look at the expansion for sine A plus B. Sine A minus B cos A plus B cos A minus B. Look at tan A plus B, then tan A minus B. You're looking at the expansion for these. Now, if you have sine A plus B, this can be expanded as sine A cos B plus, to bring the operation sign, cos A sine B. Sine A plus B is the same as sine A cos B plus cos A sine B. Now, sine A minus B is the same as sine A cos B minus, you maintain the operation sign, cos A sine B. So if you want to remember it, first write AB, and you bring the operation sign for sine A plus B. Then you write, you start with sine first, you end sine, then you bring cos. So that will be the simplest hint that I can give it to you to remember the expansion for sine A plus B. Now let's come to cos. Cos A plus B can be expanded as cos A cos B. This time around, the operation sign plus will change to negative. Sine A sine B. Cos A minus B, cos A cos B plus sine A sine B. And you come to tan. So tan will be 1 Okay, so tan A plus B can also be expanded as tan A plus B on 1 minus tan A B. Good. Then tan A minus B is tan A minus tan B on 1 plus tan A tan B. That is the expansion for compound angle. So if you have sine A plus B, remember to express or expand it or treat it as sine A cos B plus cos A sine B, and sine A minus B is equal to sine A cos B minus cos A sine B, and cos A plus B equals cos A cos B minus sine A sine B. Cos A minus B is the same as cos A cos B plus sine A sine B. We have tan A plus B, same as tan A plus tan B on 1 minus tan A tan B. Then tan A minus B same as tan A minus tan A B on 1 plus tan A tan B. Now let's look at this question. We have to simplify sine 165 degrees. Sine 165 degrees. Then you have to express sine 165 to this form. So remember that 165 is the same as 120 degrees plus 45 degrees. So sine 165 degrees can be expressed as sine 120 degrees plus 45 degrees. So now we are dealing with sine 120 degrees plus 45 degrees. Then you apply the plus 45 degrees. Saying that if you have sine A, that is two different angles. Sine, the sum of two different angles, treat it as sine A cos B plus cos A sine B. So this one will be equal to sine. This now our A is 120 and our B is 45 degrees. So sine A will be sine 120 degrees. Cos B, so cos 45 degrees. Plus cos A, which is 120 degrees, sine 45 degrees. Good. So from special angles, sine 120 is root 3 on 2 times cos 45 is root 2 on 2 1/6 plus cos 120 is 1 on 2. And we say that sine 45 is the same as cos 45 degrees. So if cos 45 is root 2 on 2, then sine 45 is the same as root 2 on 2. Good. So now let's multiply numerator by numerator, denominator by denominator. So we have root 6 on 4 plus 1 times root 2 will give us root 2 on 4. The LCM will be 4. 4 goes into 4, 1. 1 times root 6 will give us root 6. We bring the operation sign. 4 goes into 4, 1. 1 times root 2 is root 2. So now you have root 6 plus root 2 on 4, which is the same as the coefficient of the whole of this term is 1. So 1 on 4, bracket opens, root of 2 plus root of 6. So that is the answer for sine 165. Cos 15 degrees. Now, 15 degrees, same as 60 minus 45 degrees. So 60 minus 45 degrees is same as 15. Okay, so now we write cos 60 degrees minus 45 degrees, because 60 degrees minus 45 will give us 15, so it will just take us back. So we have just expanded 15 degrees. So this 15 degrees can be expanded as 60 degrees minus 45, and then it will take us back there. Okay, so now cos 60 degrees can be expanded as cos 60 degrees cos 45. For cos, if it is negative, it will become positive. Then sine 60 degrees, sine 45 degrees. Okay, so cos 60 degrees is half. Cos 45 is root 2 on 2 plus sine 60 degrees is root 3 on 2. Sine 45 is root 2 on 2. So 1 times root 2 gives us root 2 on 2 times 2 gives us 4 plus 3 times root 3 times root 2 will give us root 6 on 4. Good. So now we have root 2 plus root 6 on 4. Good. So the LCM 4. 4 goes into 4, 1. 1 times root 2 gives us root 2 plus 4 goes into 4, 1. 1 times root 6 will give us root 6. So the whole of root 2 plus root 6 has been put into brackets, and the coefficient is 1. And x equals 4 out of 5, so that cos x plus 30 degrees plus sine x plus 30 is equal to 3 out of 5. Bracket opens 1 plus root 3. So that means that after solving for this, you should get this answer. Okay. So now, in our calculation, we'll be needing cos x, and sine x has been given to us as 4 out of 5. So from the first identity, 1 minus the square of this to give us cos x. So straight away, cos x will go to 1 minus 4 out of 5 squared. This will be equal to 1 minus 16 on 25. So 1 minus 9 on 25. All root. So this will be equal to 3 on 5 cos x. So now cos x is equal to 3 out of 5. Let's take note of it. Cos s. Good. So let's write it somewhere. That sine s is equal to 4 on 5 and cos x is equal to okay. Now let's expand cos x plus 30 degrees. Let's treat, we have cos x plus 30 degrees plus sine s plus 60 degrees. Let's treat, for you know cos x is equal to 3 out of 5, so we can substitute it this way. Let's treat cos x plus 30 degrees as a single entity. So cos x plus 30 degrees could be equal to cos x cos 30 degrees is plus, so we have minus here, sine x sine 30. Take it. So now we can substitute cos x into it, cos 30 into it, sine x into it, and sine 30 into it. Okay. So we have cos x is 3 out of 5, so write 3 on 5. Cos x and cos 30, they are multiplying, so times. Cos 30 root 3 on 2. Then we bring the operation sign. Sin x. Sin x is 4 on 5. Sin 30 is the same as cos 60. So times 1 on 2. So 3 times root 3 will give us 3 root 3 on 5 times 2, 10. Bring minus 4 times 1 will give us 4, 5 times 2 will give us 10. So we have 3 root 3 on 10 minus 4 on 10, which is equal to cos x plus 8. So cos x plus 30 give us 3 root 3 on 10 minus 4 on 10. Now let's solve for sine x plus 60 degrees. For sine, this will be equal to sine x cos 60 plus cos x sine 60 degrees. Sine x is 4 on 5, so 4 out of 5 times cos 60, 1 over 2, plus cos s, 3 out of 4, sorry, 3 out of 5, times sin 60 root 3 on 2. So this will give us 4 on 10, plus 3 root 3 on 10. As sine s plus 60 degrees. So now let's come back to the main equation. Cos x plus cos x plus 30 degrees plus sine x plus 60 degrees. Cos x we have 3 out of 5 plus cos x plus 30 degrees. We had 3 root 3 on 10 minus 4 out of 10. Then we have sine 60, sine s plus 60, same as 4 on 10 plus 3 root 3 on 10. So negative 4 on 10 will do away with positive 4 on 10, leaving us 3 on 5 plus 3 root 10 on 10 plus another 3 root 3 on 10. The denominators are the same, so let's take 10. 10 goes into 10, 1 times 3 root 2 give us 3 root 3 plus 10 goes into 10 give us 3 root 3 plus 3 out of 5. So we have 3 out of 5 plus 3 root 3 plus 3 root 3 will give us 6 root 3 on 10. 2 can go into 6 at the same time can go into 10. So we have 3 on 5 plus 2 goes into 6, 3 root 3 on 5. Now let's factor 3 out of 5 out. 3 out of 5 goes into 3 on 5, 1 plus root 3. Now we say that since this expression gave us 3 out of 5 bracket with this 1 plus root 3 and it's the same as this, you can say that the expression is valid or has been proved. So please take note. That's it.